Okay, so now on the 7K, I'm also going to do this association. So we're going to say that we have VLAN 1110. This maps to the fiber channel over Ethernet vSAN 1. Under the vSAN database, we have vSAN 1 created, which technically I don't need to do because vSAN 1 always exists. It's the same as like your Ethernet access VLAN 1. You're normally not supposed to use this, just like you wouldn't use VLAN 1 in an Ethernet configuration. But in our case, since it's already working, the storage switching is already working on 1, we're just going to leave that as the default. But normally you pretty much use anything except 1. Okay, then we're going to go to the other side, which is 5K7, and we're going to configure the trunking down there. So on 5K7, let's say that we have VLAN 1110 is the FCoE vSAN 1. And on interfaces E1, 6 through 7, these are trunks and they're not shut down. Okay, on the 7K, if we look at the show interface E2 27 to 28 status, we see the Ethernet links are up as trunks. Now, in the case that you have multiple physical links between the multi-hop FCoE switches, you would normally channel these together as an Ethernet port first before you configure virtual fiber channel. And it's the same exact logic as we saw before, the links from the 5K to the MDS. If you have multiple ports, by port channeling them together, it simplifies the underlying routing table. So instead of doing equal cost routing between two FSPF adjacencies, we can configure just one port channel and then run one virtual fiber channel interface over that as opposed to multiple physical links. So what I'm also going to do here is to say on interface E2 27 to 20, actually let's say feature LACP first. On interface E2 27 to 28, we'll say this is channel group number 1110. And actually, no, I should have said mode active. Okay, so that's turning LACP on. So same thing on the other side. We'll say on these interfaces, channel group 1110, mode is active. If we look at the show port channel summary, this is simply just a regular Ethernet channel. Okay, so the port channel is up between the two of them. Next step is we're going to configure a virtual fiber channel interface and associate it with the physical underlying Ethernet. So basically what this is going to allow us to do is that when the storage traffic comes in the Ethernet port, we're going to have a virtual fiber channel that we can use as a point-to-point tunnel between the two switches. So from a fiber channel routing point of view, we would see the FSPF neighbors, we would see the FC routing table as being reachable over the virtual fiber channel interface as opposed to the physical one. And you can see this also from the UCS. When we looked at the Connect NXOS, there is a virtual fiber channel interface that is associated with the host bus adapter that goes down to the end host. So in our case here, I'm going to create interface virtual fiber channel 1110. This is going to be bound to the interface port channel 1110. So we're basically saying any Ethernet traffic that comes in the link to the 5K, we're going to associate it with the virtual fiber channel interface. The reason that I had to do the underlying port channel here is that you can only associate one interface at a time from Ethernet to VFC. So if I had two physical Ethernets, I would have to have two virtual fiber channels. But now since I have one logical port channel, one Ethernet port channel, I can have one logical virtual fiber channel interface. Okay, on the VFC interface, the switch port mode is going to be expansion because it's between the switches, and we'll say no shot. Okay, same is true on the other side. If we go to the 5K, we're going to have, and basically we could just take the same exact config. VFC1110 is bound to the port channel. And if we show interface VFC1110, what we're looking for in this output eventually is that the vSANs are up on the trunk. This here initializing means that they're trying to negotiate right now. If you see this output in a real design, it means that there's something wrong in the underlying negotiation. Okay, now it says the vSANs are isolated. Let's look at the show interface VFC1110 trunk vSAN. It says isolation due to zone merge failure. What this means here is that I had my zoning configured on the 5K, which again, remember the zoning is like an access list. On the 7K, the zoning mode was not in agreement with the 5K. So when they tried to bring up a trunk link between each other, instead of deleting the zone set, instead of deleting the ACL, they just shut down the trunk link and say, you have to fix this before I can join the fabric. It basically prevents an initiator from talking to a target that they're not supposed to. So all of the switches must always agree on the zone set, and that's one of the reasons why you would normally do enhanced zoning, which means that you can automatically advertise the zoning information between the switches. So what I'm going to do now is say that the zoning mode is enhanced for vSAN 1. And let's try to no-shut the virtual fiber channel now. Okay, now the vSAN is up. If we look at from the 7K's point of view, and we look at the show FCNS database, this switch now counts as another member of the fabric, just like any of the other previous switches that we had. So we can see end to end, we know about all of the initiators and all of the targets in the name server database, which again, the name server database is where we're figuring out what is the mapping between the port worldwide names and the fiber channel IDs. So again, the fiber channel ID, that's the logical address, that's like your IP address. Port worldwide name, that's the physical address, that's like your MAC address. Okay, additionally, if we look at the show FC domain list, this tells us that there are now 4 different switches in the fabric, where specifically it's 5K7, has a link to the 7K. This is Ethernet. It has a link to MDS3 that is native FC. Then we have a link to MDS1 that is native FC. And then we have the actual SAN. Okay, the UCS is down here right now, go in that direction. So if the MDS here had native fiber channel over Ethernet ports, we would be able to do a connection there, or if the SAN had FCoE ports, we would be able to do a connection there, and then we would be able to use the 7K basically as the core aggregation switch for FCoE. Now in my particular topology here, this design doesn't make any sense because there's no reason to switch through it with multi-hop FCoE unless we're going towards the target. So the physical design would have to be different in order for it really to make sense to use the 7K for FCoE. But I just wanted to show you guys what the overall result of the configuration looks like. So if we look at show run inside the storage VDC, we can see that the zone set information was automatically learned. So as soon as we join the trunk link, join the expansion port between them, we learn the zone set. Then on the physical Ethernet ports, we have these in a port channel. The port channel traffic is then associated with a virtual fiber channel interface. And this is the expansion port that we have the connection over to the 5K. So if we look at the show interface brief, we should see that the virtual fiber channel is a trunking expansion port. We see it's a 20 gig connection. From the 5K's point of view, if we look at the show interface brief and look at the, let's say, pipe include FC, or just FC should be fine. the physical fiber channel interfaces and the virtual fiber channel interfaces basically behave the same. The main difference is that the speed of the native fiber channel links is lower than what the Ethernet is. So one of the advantages in a real design of this is that currently fiber channel goes up to 16 gig. There are some additional specs that are coming out for 32 gig and higher, but you could technically take the Ethernet ports that we already have now, which are 40 gig and 100 gig Ethernet, and use those for dedicated core SAN switching and basically skip over the need for the higher fiber channel speed ports. So the native FC is technically only needed in the case that the storage array has native fiber channel ports. And most of the new SANs nowadays, you can either buy FCoE ports or FC ports. It just depends on what the port density is, and then the per port cost between the two of them. Okay, there was a question here on the UCS side. When we look at the connection from the virtual interface card to the FI, so let's connect NXOS, and let's look at the show fabric login. Actually, no, show NPV Floggy table. What this shows here is the virtual interface card. Make sure the VHBA that I had configured in the service profile, we see this logging in on the virtual fiber channel port. Now, what this is from a physical connectivity point of view is the logical equivalent of what we have in the diagram here for the 5Ks connectivity down to the standalone server. Because remember, the 5K and the UCS FI are literally the same platform. The link that is going down to the fabric extender, this is what we have configured as VN tag. This is the same as what the fabric interconnect has down to the I/O module. Then the I/O module has a physical link to the blade server. That's like this physical link that we have down to the converged network adapter. So in this type of design, basically the blade is logging into the fabric interconnect. The fabric interconnect is running both NPIV and NPV. So it's proxying the login from the blade to the upstream switch, and it's running NPIV because the blade is going to have multiple different logins. So from the FI's point of view, if we look at the show run pipe include feature, this design is essentially nested NPV. So it's running both node port virtualization and node port ID virtualization. So in both cases, this counts as single hop NPV. Now, as we go to the northbound switches, we can go from the UCS FI up to the 5K with FCoE. This means that the 5K would need to be running FCoE NPIV, where specifically this port here is going to be an F port. This port here is going to be node proxy, where technically these are going to be virtual node proxy and virtual F because they're for FCoE. Now, from the UCS point of view, this is actually a really straightforward config from the GUI. The only thing that you need to do is, and let's look at the physical connectivity. This would be on, this is going to be on Ethernet 1.9 on the UCS side and 1.12 on the Nexus side. So let's go to the UCS, and let's go to equipment, fabric interconnect A, the fixed module, and this was Ethernet, again, what did I say? This is Ethernet 1.9. So we're going to say port number 9 is configured as an FCoE uplink. Okay, it says role is FCoE uplink. Virtual SAN is vSAN 1. The mode is trunking. If we look at the end result of this from the CLI point of view, and we look at the show run interface Ethernet 1.9. It says this is a trunk, and the VLANs that we have are some other VLANs we had created. The one that is important, though, is this 1110. This is the mapping from VLAN 1110 to vSAN 1. If we then look at the show interface brief, what we're looking for here is a virtual fiber channel interface that should be bound to the physical port Ethernet 1.9, which is this. So this now means from the UCS point of view, when it is looking at the physical connectivity, and let me draw this out here. So we have the actual blade that has the VHPA 1 on fabric A. Okay, this goes to the I/O module. The I/O module is then going up to the UCS fabric interconnect. And the fabric interconnect, this is the VN tag port. Okay, that's the FEX port. Then we have the link that goes to the 5K. This interface here is going to be configured, well, technically not that one. It's going to be actually on this port here that goes to the VHPA. This is our virtual fabric port where the, well, we could say it would probably be right there. The virtual fabric port, and the VHPA is a virtual node port, or sometimes what's referred to as a E-node. Okay, an E-node means an FCoE end host. Then we have from the I/O module up, this is going to be a virtual NP port for the virtual fabric port that the UCS has. Okay, this is where the nesting now comes in. That we have another virtual node port that goes up to the virtual fabric port on the 7K in order to proxy the login all the way end to end. So this means the UCS is running NPIV in order to get the login from the blade, but it's also running NPV in order to log in to the upstream switch, which means the upstream switch needs to run NPIV. So it's basically multiple levels of proxying in order to get the VHPA to log into the final upstream switch, which is going to be on the northbound side. So from a connectivity point of view, this could either be the 5K or it could be the 7K. And in the case of the 7K, that would be the storage VDC. Okay, so the port that it shows was virtual fiber channel 703. Let's say show run interface VFC 703. It says it's bound to interface E19. The switch port mode is node proxy. This means it's running NPV. Now on the other end of this, where physically E19 goes to E112 on the 7K side, we're going to say that on interface E112, the switch port mode is trunk, and the spanning tree port type is edge trunk. Remember, we talked about this within the scope of spanning tree. Since the fabric interconnect does not do switching, we need to make sure that it is not participating in spanning tree. So from the upstream switch's point of view, if it sends a rapid spanning tree proposal, the FI is not going to respond to that. So the end result is that if it's not configured as edge trunk, all the blades will be knocked off of the network for 30 seconds every time there is a convergence event. And in this case, if we're doing FCoE as well, the storage traffic is going to drop. And if they have their disks that are booting from the SAN, you lose access to your boot disk, basically the server is just going to crash. So it's not a recommendation, it's a requirement that whatever switch you're running on the north side runs as edge trunk as it goes down to the UCS-FI. Okay, if we then look at the show interface E112 status, the Ethernet trunk is up. Next is we're going to bind this to a virtual fiber channel port. Now, since the downstream switch is running NPV, it means the upstream switch needs to run NPIV. This is what is allowing multiple fabric logins to come in on that interface. Normally, you only allow one FCID assignment to one PWWN. You can think of it kind of like port security in Ethernet. If you're only allowing one end host, that's the default behavior of Fiber Channel. But the NPIV feature is saying you're allowed to have multiple IDs virtualized on that particular port. Okay, next we're going to create an interface VFC. We'll say this is 112 that is bound to the interface E112. The switch port mode is F for fabric. If we now look at the show interface VFC 112, we should see that vSAN1 initializes, which is going to be the number that we're running on the UCS, which it is. So if we now look at the show fabric login database, this value here, this is the UCS logging in as an NPV host. So if we were to look at the show fabric login or the show FCNS database, this here on the local port 58, this is the actual UCS. This is the initiator. So it basically means now from the UCS point of view, we have multiple ways that we can reach the target. We can go native fiber channel to the MDS, or we could go over the Ethernet links to the 5K. And which direction it chooses is going to be the same thing that we talked about in the UCS section that's related to the LAN switching. The VHBA is going to be pinned to only one of the uplinks at a time. And the way you can see that is by looking at the show NPV external interface usage. That the actual blade VFC 702 is mapped to fiber channel 111 right now. So it means that the blade's traffic, when we look at this from the physical point of view, the blade's traffic is currently going that direction, even though it has multiple paths. It has the first path, FC111, it has the second path, FC112, and then it has a third path, which is E19, that is the FCoE uplink. Now, of course, we could change this on the service profile. We could configure a SAN pin group, where the SAN pin group is going to manually map the blade to an outgoing interface, and then it's going to be required to use that as it goes to actually send the traffic. Now, as a simpler example of this, what I'm going to do is just shut down the other ports and then reboot the blade. That's going to force it to use the Ethernet uplink as opposed to the FC uplinks. So I'm going to say on FC 11 and 12, I'm simply going to disable those. And then on the blade, just reset the server. So what we should see as the end result of this on the 5K is when we look at the show fabric login database, we should see the virtual HBA, which I assigned it that port worldwide name, that should now log into the 5K. And the 5K already has the zone set configured that is associating the initiator and the target because the zone set is fabric wide. So basically, no matter which way it comes into the network, it's still manually mapped. It's saying those two, the initiator and the target, so that the server and the storage are allowed to talk to each other in the FC switching network. Okay, while we're waiting for this to boot, there were a couple questions. One is, does the 5K require storage protocol license to run FC, FCoE, both, or either? There's two different ways you can do it. If you look at the show license usage, there is an FCoE NPV license and there is an FC features license. Now this one here is the full FC switching license. This one here is just FCoE that connects to an NP-IV switch. So what this top one would allow you to do is to take the converged network adapter, plug this in to the 5K. Okay, you could also have effects in the middle. and then the 5K go up to the 7K or the MDS over FCoE, where these upstream devices would be running NP-IV and the 5K would be running NPV. This is the logical equivalent of the UCS Fabric Interconnect in end host mode. So both the 5K and the UCS can run in end host mode. The difference is that the UCS does that by default. The 5K is going to run in whatever mode depending on how you enable the features. Now, just like in the case of the UCS, if you go to move between end host mode and switching mode, it does require a reboot of the box. The same would be true on the 5Ks. So if we were to go to, let's say, 5K8, and we say globally feature NPV, or actually feature FCoE NPV. What this is going to tell us, I believe here, is actually no. Let's say no feature FCoE NPV. If we say no feature, or if we say feature FCoE, I have to reload. The issue is that when you go into end host mode, the box requires a reboot in order to do it. So just like the unified ports, it's something that you would have to plan in advance in your implementation, that you set the mode correctly before you install the switch, or not necessarily before you install it, but before the servers are actually using it for forwarding, because it is disruptive for the data plane in order to do that. Additionally, when you move into NPV mode, which is end host mode, it deletes the config of the switch. So you need to make sure that you have a backup copy like in Notepad or text file or something, so you can reapply whatever Ethernet configuration that you had to the switch. And it does actually warn you when you go to do that. If I had said feature FCoE and then feature NPV, it says you can do this, but you're going to have to reboot and erase and reboot in order to do it. Okay, so now that the blade is rebooted again, if we look at the Fabric Interconnect, we should see the difference is now that the external interface is now the virtual fiber channel, which really means E1/9. So if we go to the 5K on the other side and look at the show fabric login database, now we can see that the blade logged in, and this is the path of where it's actually sending the storage traffic. Okay, the other option we have is to run FCoE down to the converged network adapter, which is the one that we have plugged in here to the fabric extender. The configuration for this is basically going to be the same exact thing as what we had from the 5K to the UCS. The only difference is that we're binding it to the fabric extender's port as opposed to the locally connected port. Now, in addition to that, in our previous design, we had configured enhanced virtual port channel between the two 5Ks, which means that both parents are servicing both fabric extenders, which also means they're both controlling both downstream interfaces. Now, there's a potential design problem that you can run into with this case. It's that when the storage traffic comes up from the converged network adapter, so from the end server, and it gets to the FCs say, I can hash my traffic to the left and I can hash my traffic to the right. But the whole idea of the storage network is that we have physical separation of the A side of the fabric versus the B side. That on the disk physically, there's multiple access from the controllers that we have different physical paths. So if MDS1 goes down or the links between these two go down and we lose the A side, the server should still be able to reach the storage by going to the B side. But the problem is if we break that separation by being able to go both directions from both NICs, then we might have a failure that we're not able to recover from. So in this very specific design, when you are combining enhanced virtual port channel with fiber channel over Ethernet at the same time, there's going to be a separate config you need to do on the FCs to make sure that the FCoE traffic stays separate. So in other words, only one of the upstream 5Ks can control the 2K for the purpose of FCoE. So we would say that these two run FCoE together that direction, and these two run FCoE in that direction. This would keep our SAN A and SAN B separation. And the way that we specifically do that is under the fabric extender, under the FEX associate, where it looks like FEX was, let's say show run FEX. FEX, or not FEX associate, just FEX 101. We would say FCoE. So this now means we're telling the extender that if you have any fiber channel over Ethernet traffic to send, you can only send it to me, you cannot send it the other direction. Then likewise, we would go to the other parent switch and we would say under FEX 102 that you are the one that is sending FCoE to the upstream parent switch. So it's trying to keep the SAN A and SAN B separation. But if we were to look at this config down to the end host, let's say we show run interface VFC 1112 or 112, this config would be identical as we go down to the, what is the fabric extenders ports? Let's say show interface status. It is, oh, it's a port channel. Let's say show port channel summary. And the module is removed. This means that the FEX is not powered on right now. But basically, the config would be the same, just that we would bind the physical interface here to the virtual fiber channel. So the end result is that even though you have the same parent switches that are servicing the same downstream fabric extenders, they would have different configurations. So again, it's kind of the case where by adding additional links, you're not really adding more redundancy, you're just adding more complexity to the network. Because in this design, with the 5Ks servicing multiple extenders, you still technically have a single point of failure anyways, that if the FEX goes down or the parent switch goes down, you're not going to be able to hash that direction regardless. So a simpler design would be to just remove these cross-connected links, and then you would service the fabric extenders down to the servers separately. So as we talked about, it is a supported design to do the eVPC, but from an operational point of view, I would say it's kind of overly complicated in order to actually do that.